The future of drone operations is taking shape faster than many people expected, and a recent demonstration by Shield AI and Destinus is showing just how advanced autonomous aviation has become. The two companies recently teamed up to showcase the power of Hivemind autonomy software, a system designed to allow multiple unmanned aircraft to work together as a coordinated team. Instead of relying on constant human control, these aircraft can communicate, adapt, and carry out missions with a high level of independence, making operations more efficient and effective. At the center of this demonstration were two impressive platforms, the VBAT unmanned aerial system and the Destinus Hornet. Working together, these aircraft demonstrated how autonomous systems can expand their reach and capabilities in challenging environments. Rather than operating as individual drones, they functioned as a connected network, sharing information and coordinating actions in real time. During flight tests conducted in Choctaw, Oklahoma, the teams put this technology through demanding scenarios. One of the key achievements was the creation of a resilient mesh communications network. In this setup, the VBAT served as an airborne communications relay, connecting the ground control station with multiple Hornet aircraft operating farther away. This allowed information to flow across the entire network, helping the aircraft stay connected even in complex operating conditions. Before takeoff, mission plans were uploaded to the autonomous team, giving the aircraft a clear set of objectives. But real-world missions rarely go exactly as planned. Conditions can change quickly, requiring immediate adjustments. That's where Hivemind demonstrated its strength. During the flights, new instructions were sent to the aircraft while they were already in the air. The AI successfully adapted flight paths and coordinated the different platforms as the situation evolved, all without requiring operators to manually manage every detail. The Destinus Hornet is already a highly capable and agile aircraft, but coordinating multiple autonomous systems can become extremely complicated. Hivemind acts as the central intelligence that makes this possible. It can manage formation flying, synchronized timing, coordinated maneuvers, and even ensure multiple aircraft arrive at a target location simultaneously. Instead of spending hours planning every route and movement, commanders can focus on defining mission goals while the software develops the most effective plan. Human operators still maintain oversight, reviewing and approving the mission, but much of the complex planning is handled automatically. This capability becomes especially important in modern environments, where GPS signals and communications networks may be disrupted or deliberately jammed. Traditional navigation and control methods can struggle under those conditions, creating major challenges for drone operations. Hivemind is specifically designed to overcome those obstacles, enabling autonomous aircraft to continue navigating and carrying out their objectives even when conventional systems are unavailable. The successful demonstration highlights how far autonomous aviation has progressed. It shows that AI-powered systems are already capable of connecting, coordinating, and scaling collaborative drone operations in ways that were once considered futuristic. As technology continues to advance, autonomous fleets working together could become a common sight, helping military and commercial operators perform complex missions more efficiently while reducing the burden on human crews. The future of intelligent drone teamwork is no longer a concept on the drawing board. It's already taking flight.